ProbStats kids, this is Dr. Callahan with week 11 Friday. How are you guys doing? I hope you're having a wonderful week. So go ahead and pause the video and answer the following 3 questions, and we will get started shortly. Just to put a few things into perspective, this week is week 11. Today is Friday. Next week is week 12, and your finals week is week 18. So after this week, you will have exactly 6 weeks until finals, or actually more like 5 weeks until the week of final, which is week 18. All right, you guys, take a look at the breakdown for today. So your job is to go ahead and we're going to talk about part 2 of using measurement variations for page 8. We're going to start on page 8. We're going to talk about the distribution of a bell curve. You're going to draw a bell curve and label. You're going to need 3 colors. I'm going to go ahead and have you guys do a bell curve data collection activity where you're going to find the standard deviation and the variance. And then your homework tonight is going to be right over here on 30, 30A, and 34. Make sure you guys go to the Google Doc for week 11 and go to Friday. All right, so then with that said, let's go ahead and jump right in. So there are certain topics that you can use with numerical numbers, like if you want to compile certain things to find the standard deviation of people's shoe sizes, like how vastly different are people's feet. You can also do the hands, somebody's size of their hands in inches. You can go ahead and do their GPA from 0 to 4.0. You can do the number of relationship you've been in since high school or middle school even. Credit attainment, how many credits you have. Numbers of siblings, brothers and sisters or cousins. And so you could do any of that on your own. And you will need to find 15 people, make it up if you have to. It should be 1-0. Find the mean, standard deviation, and create a bell curve distribution afterwards. Okay, so if you're not in class today in person, this is a worksheet that you want to grab from me when you guys come up in person. And I want to talk a little bit about this. But before I do that, I want to make sure that you guys have enough time to go over your notes. So let's dive right into page 8. So page 8 is you can use empirical rules to interpret standard deviation and approximate the sample standard deviation for the grouped data. So first thing we want to talk about is the following. When you're working with a bell-shaped distribution, this is often described as a normal distribution, and this is a bell curve where the x is going to be your mean, and it's right in the middle of your bell curve. The entire area under the curve area is this part right here. The entire area is always going to be 100%. And the information you're going to need to make the bell curve is you need to have your average and your standard deviation. So when you're creating a diagram using mean and standard deviation for the data with a normal bell-shaped curve distribution, the standard deviation can't be used to separate data into sections. So once again, the mean is right there in the middle. And the first bar is a +1 standard deviation, then 2 standard deviation, 3 standard deviation. So it's sectioned off. On the left side is -1 standard deviation, -2 standard deviation, -3 standard deviation. So again, you're sectioning it off. So for example, a math test has a normal distribution and the mean is 72% with a standard deviation of 6. Draw the distribution. So what we're going to do is we are going to start off with a mean, 72%. So right here is 72. Then it has a standard deviation of 6. So what that means is that one standard deviation, it is going to be a 72 plus 6, which is going to be a 78. So that's a 78% with like somebody who got a 78% on the test, okay? Then if somebody got a 2 standard deviation, it is going to be a 72 plus 6 plus 6, 2 times. So that will be a 84%. So if I got 84%, that means I'm 2 standard deviations above the mean. And then if it's 3 standard deviation, it will be a 72 plus 6 plus 6 plus 6, which is going to equal to a 90th percent. Okay? So that is how you break it down with standard deviation, is you basically just add the standard deviation to the mean, and one time, 1 standard deviation, add it twice, 2 standard deviation, 3 times, 3 standard deviation. Okay, then with that said, let's go and take a look at the left side of that. Okay, remember the mean again is going to be a 72. So then if it's a minus 1 standard deviation, you guessed it, 72 minus 6, which is going to give you a 66%. Minus 2 standard deviation is a 66, or actually I should say 72 minus 6 minus 6, which is a 66 minus 6, and that's a 60%. Minus 3 standard deviation is a 72 minus 6 minus 6 minus 6, which is a 54%. 3 standard deviation, 2 standard deviation, 1 standard deviation. So go ahead and copy that part down. All right. So then let's take a look at the next part of this. Okay, so then there is an empirical rule that we oftentimes use with standard deviation, and it's a 68, 95, 99.97 rule, okay? And this is the part that I want you guys to go ahead and copy down. Okay, so for data to be normal, the distribution of the standard deviation has to follow the following characteristics. At 1 standard deviation, so that is going to be right here, you guys. It's going to be 1 standard deviation to the right side, 1 standard deviation to the left side. It's always 34 and 34. So when you add them together, that's 68% of the area of the bell curve. Okay. The next part is always 13.5 and 13.5. That's 95%, because, and you're like, how do you get 95%? It's 34 plus 34 plus 13.5 plus 13.5. So 95% of the data lies within 2 standard deviation. And the next part is this, you guessed that this little piece right here and this little piece right here, that's 3 standard deviation. So if you just take 95 plus 2.35 plus 2.35, that's going to lie within 99.7%, which is going to give you plus or minus 3 standard deviation from the mean. So the bigger the standard deviation means that you're further away from the mean. Okay, so let's go ahead and take a look at this. So it says, in a survey conducted by the National Center for Health Statistics, the sample mean height of a woman is 64 inches. So that is the average height. And if you're not quite sure what that means, remember there are 12 inches in a feet. Most people are at least 5 feet, so that has to be 60 inches. So if you have 64 inches, that's converting it to 5 feet 4 inches is how tall the average woman is. I know they're using inches, and we're like, what does that mean? Like, how tall is that? And so let's go ahead and draw this. There's my bell curve. And then if I were to go ahead and make my data, my mean is right here. That's my mean. My average is 64 inches. Standard deviation is 2.71. So that means at the 1 standard deviation, okay, that is going to be a 64 plus 2.71, which is 66.71 inches at the 1 standard deviation. Then at the positive 2 standard deviation it is a 64 plus 2.71 plus 2.71, which is then going to give me, and I'm going to grab my calculator and do that. 64 plus 2, oh, hold on, 66.71 plus 2.71, which is going to give me 69.42 inches. And then at the third standard deviation, that is going to give me 64 plus 2.71 plus 2.71 plus 2.71, so 3 times. And that's going to give me a 72.13 standard deviation, or inches, for the third standard deviation. So right here, and right there. Now on the counterpart of this, we also have to find the negative standard deviation. So I'm going to go ahead and draw my -1 standard deviation. So that's going to be a 64 minus 2.71. And that's going to be a 61.29 inches. And then of course you have I'm running out of space here, that's what I'm going to write it down here, -2 standard deviation. So that is a 64 minus 2.71 minus 2.71 minus 2.71, or I'm sorry, went a little bit ahead of myself. It's just twice, not 3 times. So minus 2.71, it's going to give me a 58.58. And then at the third standard deviation, so -3 standard deviation, it is going to be a 64 minus 2.71 minus 2.71 minus 2.71, so essentially 3 times, and you have a 55.87. And so therefore this is going to be your standard deviation. 61.29 inches is going to be the -1 standard deviation, 58.58 -2 standard deviation, 55.57 -3 standard deviation. And this is your answer. All right, you guys, so next what I would like you guys to do is you are going to take a measurement if you have a ruler at home and fill this part out with this little chart right here. You're going to go ahead and pick some kind of a data. Like I use height. You can also make up shoe sizes. What do you think the average shoe size is? I wear a size 6.5 boots and size 6 for sandals. So yeah, you can even do like the size of somebody's hand in inches. You can come up with GPAs, whatever you want to do. You're going to make up those numbers and you're going to go ahead and put those numbers of, let's just say, shoe sizes right here. So I'm just going to go ahead and say, okay, maybe a 6, size 6.5, 6, 6, 7, 7, 7, maybe a 10, 11, 12, probably not 18. I don't think most people have 18. 13, 13.5, 9, 9, and 8. Okay, so those are all the shoe sizes for women in the US. Now, what you're going to do is you are going to find the average of this. So you're going to do the sum and then divide it by 15. Okay, whatever that's going to be. So then what you're going to do is you're going to take these numbers and go, okay, 6 minus the sum is going to give me another number. Okay, so you're going to do that for all of them. So take a look at the little red lines I'm writing. You're going to fill that out. Okay, so make sure you continue that. And then remember the epsilon means sum. So you're going to essentially add everything here, the sum of this, and you're going to write that in this little box. After you do that, you're going to go ahead and square them to find the variations. So you're going to take whatever that number is, okay, and square it. So it's always going to be this number time the same number, and you're gonna get a bunch of numbers right here in green. And make sure you do that for all of them. And what you're gonna do with that is you're gonna add them all together and put it right there. Now, your standard deviation, the way you calculate it is you're gonna take that number right here, divide it by 15, and that is gonna be your standard deviation squared. So then in order to find your variance or standard deviation, because this is your variance, you are going to take that number, which is this number right here, and you're going to put it in a square root, which will give you your standard deviation. And then once you have your standard deviation, which is awesome because remember to do this, you got to have your standard deviation and you also have to have your mean. You're going to take those two numbers and you are going to create this beautiful bell curve and then start labeling them like that, just like what we did for today's class. And then so I have the rubric right here. Okay. All right, you guys, I hope you have a wonderful day. And as always, stay safe and healthy. And I will see you guys next time. Take care.